299,790 meters per second. That is the speed of light in a vacuum, not approximately, not rounded. Exactly that number, by definition, because in 1983, the international scientific community got tired of measuring it and just defined the meter in terms of the speed of light instead. Every particle of light that has ever traveled through space has traveled at exactly that speed. No faster, no slower. Not because light chooses to, but because it has no choice. Photons have no mass. Zero. The rules of the universe say that any massless object moves at exactly c. It can only move at c, not c minus 10, not c plus 5. Exactly c. Everything else with mass cannot reach it. No matter how much energy you add, you will get closer and closer to c and never arrive. This is the speed limit. And physics can tell you exactly what happens because of it. Physics can tell you with extraordinary precision how time slows down as you approach it, how distances contract, how mass and energy turn out to be the same thing, how causality depends on it. Physics has tested this in particle accelerators, in GPS satellites, in atomic clocks on airplanes. The consequences of the speed limit are confirmed beyond any reasonable doubt. What physics cannot tell you, what nobody has ever explained, is why the universe has a speed limit at all. That is the question this video is about. To understand why the speed limit is surprising, you have to start with the world before it. Isaac Newton built a physics where velocities simply add. If you throw a ball at 10 meters per second from a train moving at 10 meters per second, the ball travels at 20 meters per second relative to the ground. This is obvious. It is also completely wrong for light. In Newton's universe, there is no maximum speed. You could keep accelerating forever in principle. There is no built-in limit. Space is a fixed background, time ticks at the same rate everywhere, and speeds add without complication. This worked for 200 years. Planets, cannonballs, ocean currents, all of it obeyed Newton. The machinery was perfect. Then James Clerk Maxwell wrote down 4 equations describing electricity, magnetism, and light. From those equations, the speed of light could be calculated. It came out to roughly 300,000 kilometers per second, and it was the same regardless of how fast the source of the light was moving. The equation said nothing about the motion of the observer or the source. Light just moved at c. This was a serious problem. If light moves at c relative to what? In Newton's universe, speeds are relative to something. The ground, the air, the train. Light needed a medium. Physicists invented one, the luminiferous aether. An invisible substance filling all of space, and light was a wave moving through it, the way sound moves through air. In 1887, Albert Michelson and Edward Morley built an instrument to detect the ether. The Earth moves around the Sun at roughly 30 kilometers per second. If the aether was filling space, the Earth was moving through it. And light should travel at slightly different speeds depending on whether it was moving with or against the direction of Earth's motion through the ether. The same way sound is faster with a tailwind than against a headwind. Michelson and Morley built an interferometer that split a beam of light in two, sent the beams along perpendicular paths, and looked for tiny differences in their travel times. The instrument was sensitive enough to detect a difference? They found none. Light traveled at the same speed in every direction, regardless of which direction the Earth was moving. They repeated the experiment. The result was the same. Other experimenters repeated it. Same result. The aether did not exist, or if it did, it had no effect on light. This broke something fundamental. If light always travels at the same speed regardless of the observer's motion, then the obvious physics of Newton cannot be completely right. Something had to give. George Fitzgerald and Hendrik Lorentz tried to save the ether. They proposed that moving objects physically contract along their direction of motion through the ether by just the right amount to make the speed of light appear constant. This worked mathematically. It was also epicycle-level contortion, adding new assumptions specifically to protect the old assumption. In 1905, Albert Einstein did something different. He did not try to explain the Michelson-Morley result, he made it a postulate. Einstein started with 2 assumptions. First, the laws of physics are the same for all observers moving at constant velocity relative to each other. Second, the speed of light in a vacuum is the same for all such observers, regardless of the motion of the source. That is it, 2 postulates, and everything else follows from the mathematics. What follows is strange. If the speed of light is constant for all observers, then time cannot be constant. 2 observers moving relative to each other must disagree about how much time has passed between 2 events. A clock on a fast-moving spacecraft ticks more slowly than a clock at rest. This is not an illusion. The clock genuinely runs slow. When the spacecraft returns, less time has passed on it than on Earth. This has been verified with actual atomic clocks on airplanes. Length contracts in the direction of motion. An object traveling at high speed is shorter in the direction of travel than the same object at rest. Not because anything physical is happening to it, but because length and the direction of motion and time are part of the same structure, and they trade off against each other as speed changes. Simultaneity disappears. Two events that happen at the same time for one observer do not happen at the same time for a different observer in relative motion. There is no universal now. The present moment is local, not global. And then there is E equals mc squared. Mass and energy are the same thing. Stationary mass is frozen energy. Add enough energy to a massive object, and you have to add it to the whole package, rest mass plus all that kinetic energy. As you approach C, the total energy needed to keep accelerating grows without limit. Not because you are pushing against some wall, but because you are accelerating an object whose effective inertia has grown enormous. To reach C, you would need infinite energy. There is no path from here to there. None of this is controversial. Particle accelerators push electrons to 99.99999% of the speed of light, and the behavior matches the equations exactly. The Large Hadron Collider depends on relativistic corrections to function at all. GPS satellites tick faster than clocks on the ground because of gravitational time dilation, and tick slower because of velocity time dilation. And the engineers have to correct for both or the coordinates drift by several kilometers per day. Muons created in the upper atmosphere by cosmic rays travel far enough to reach the Earth's surface only because their internal clocks run slow relative to ours. They live longer from our perspective than they do from their own. This is not metaphor. This is routine experimental observation. The speed limit is not a hypothesis. It is a measured, applied, institutionalized fact. The causality argument makes it even harder to escape. Suppose something could travel faster than light. In special relativity, an observer in a different frame of reference moving fast enough relative to you would see that something arriving before it left, literally, in the mathematics. In another frame, the sequence of events is reversed. A signal arrives before it was sent. If you chain two such signals together, one going, one returning, you get a message received before it was transmitted, an effect before its cause. The universe would have no consistent timeline. Physics says this cannot happen. The speed limit enforces it. Now here is where the honest answer runs out. Why does the universe have a speed limit at all? This is different from asking what the speed limit is or what it does. Physics knows those things well. The why, the deeper reason, the one level down, is genuinely unknown. The speed of light is related to a number called the fine structure constant, approximately 1137. This pure number, without units, captures the strength of the electromagnetic interaction. It determines how electrons and photons interact, how bright atoms glow, how tightly electrons orbit nuclei. It is one of the fundamental constants of the universe. Richard Feynman called it a magic number that comes to us with no understanding. Physicists have been measuring it more precisely for decades and have never been able to derive it from first principles. Nobody knows why it is 137 and not 137 and not a 13 or 1200. The speed of light is connected to this number. Change the fine structure constant and the speed limit changes too. But that just moves the question one level back. You have not explained why the speed limit exists. You have explained which constant it is connected to, and the constant is equally unexplained. The numerical value of c in meters per second is arbitrary, because meters and seconds are arbitrary human inventions. Physicists sometimes work in units where c equals 1, which makes the equation simpler and makes clear that the number is not fundamental. What is fundamental is that a finite maximum speed exists at all. That the universe is built with a speed limit baked into its structure, that this limit is the same everywhere, at every time, for every observer, and that physics cannot say why this should be so. That is the honest answer. The speed limit is real, its consequences are verified, the reason it exists is unknown. Everything physics knows about the universe fits inside that limit. So far, everything stays inside it. Whether it is a feature of the deepest structure of reality, or a property of this particular universe, among many with different constants, or something that future physics will eventually explain, nobody knows. The speed limit is 299,790 feet meters per second. We know exactly where it is. Its fingerprints are on every particle accelerator, every GPS satellite, every muon that survives long enough to touch the ground. The speed limit holds up under every test we have ever designed. We just have no idea why it is there. Physics has no good answer. At least, not yet.